And today we are going to see subject geotechnical engineering, and in geotechnical engineering we are going to study what? Consolidation settlement. We are continuing our journey of geotech, and in geotech we are studying consolidation, right? So yesterday we have already discussed the basic process or theoretical understanding of consolidation settlement, right? So yesterday, those who have missed that lecture, they can go to the BYJU'S Exam Prep GATE official channel, and there they can see that particular lecture, right? So today we are going towards what? Consolidation settlement. Means what? Delta H. Means what? Delta H. Okay. So first of all, before going into this delta H, okay, let us have a short introduction of me. So my name is Satyajeet Sahu. I have done my BTech in civil engineering from IIT Kharagpur, and then I have done my masters in structural engineering from IIT Kharagpur only. After that, I have been selected into Indian Oil, HPCL, DMRC, RITES through GATE. Okay. After that, I have served as design manager in Delhi Metro Rail Corporation, and I have more than 10 years of teaching experience. Okay. And I have taught all across the nation. Okay. And I teach all the civil engineering subjects. Okay. So, coming back to today's lecture. Today's lecture is about what? Consolidation settlement. Now, whenever I say the term consolidation settlement, whenever I use this term known as what? Consolidation settlement. Whenever I use this term known as what? Consolidation settlement, you should understand that we are talking about which settlement? We are talking about primary. We are talking about what? Primary consolidation settlement. We are talking about what? Primary consolidation settlement. Because they are going to ask this only. They are going to ask what? Primary consolidation settlement. We have already seen that we have two types of settlement. First one is what? The primary consolidation. Second one is what? The secondary consolidation, right? But when we see our GATE syllabus, the question are asked from where? From your primary consolidation settlement. From your primary consolidation settlement, right? And that we will call as what? Delta H. That will call as what? Delta H. Okay. There's a small technical error. I will just correct that and then we'll be back to the lecture. Thank you for your patience. So we're back to the lecture. Okay. So suppose we have a soil mass like this. Suppose we have a soil mass like this. Okay. Now this particular soil mass will have some void ratio, and that void ratio, suppose I'm calling that as E naught. What is this E naught? This is the initial void ratio. This is what? The initial void ratio. Initial void ratio. Now, tell me when it consolidates, when there is primary consolidation happening to this soil. Primary consolidation happening to this soil. Tell me the volume will increase or decrease. Tell me the volume will increase or decrease. The volume will increase or decrease when this saturated clay, I can say, is saturated clay. See, it will not be round in shape. It is just to indicate, okay. This saturated clay, okay, there will be reduction in volume or increase in volume. Please mention in the comment section. Will there be increase in volume or reduction of volume? Yes, there will be reduction in volume. Yes, So saturated clay, when there is primary consolidation is what? Primary consolidation is expulsion of water from voids. So when this happens, I can say the volume will reduce. Okay, this volume will reduce. So I can say in the process of primary consolidation, we are having a reduction of volume. We're having what? A reduction of volume. A reduction of volume. Okay. Now, the final void ratio, suppose I am calling that as EF. This is what? Suppose I am telling this as final void ratio. And obviously, since the volume has reduced, the initial void ratio will be more than the final void ratio. Yes, I can call this as E0, the initial void ratio, or I can give the name E1, yes, or I can give the name E2. That varies from books to books, so we'll not go into the exact terminology. But some books write E0 for the initial void ratio, or we can write down E1 and E2 or EF for the final void ratio. So I can say that this is what? Before consolidation, right? Yes, this is what? Before consolidation. This is the soil sample, okay? Or I can say the clay layer before consolidation. And this is after consolidation, right? This is after consolidation, okay? This is after consolidation. Now tell me, when I'm comparing the stresses, suppose the effective stress before consolidation, the effective stress. Now tell me where we calculate the effective stress in the clay layer. Tell me, in the clay layer, where we calculate the effective stress. Tell me in the clay layer, where? Welcome Sanju Jacob, he is writing, I am your big fan. I am also a big fan of Sanju Jacob, he is my good friend. So we can all welcome Sanju. So all the students can also welcome Sanju Jacob to the class. Okay. Okay, so that is a welcome to Sanju. Okay. Apart from that, also you write down the answer that tell me that where we calculate the effective stress in a clay layer. Yeah, very good. We calculate the effective stress at the mid depth. Correct. Okay. Now, suppose the effective stress before consolidation is sigma 1 dash and after consolidation is sigma 2 dash. Now tell me which one will be more? Don't tell, I am telling you. Obviously sigma 2 dash is more, because we have seen yesterday, or we know this also before, that consolidation happens, right? Consolidation happens due to additional stress coming into picture. So I can summarize this as by telling that the stress was sigma 1 dash, right? The effective stress was sigma 1 dash and the void ratio was E1, right? This is the initial condition. After consolidation, what happened? There was addition of this delta sigma additional stress and the effective stress became how much? Sigma 2 dash, right? And the void ratio changed to E2. Now this initial void ratio can be written as E1, or some books write down E0 also, right? And this is written as EF also. Understood? Very good. Very good. You're doing very good. Okay. Now, so I can say during the process of this primary consolidation, what is happening? Void ratio increases or decreases? Decreases. Void ratio decreases, yes, and your effective stress increases. Effective stress increases. So there can be a relationship between this void ratio and effective stress, and these relationships are used for calculation of your settlement. So first of all, we'll see those relationships and we will define some of the parameters. You might have heard those parameters, right? You might have heard about coefficient of compressibility, compression index, coefficient of volume, compressibility. So all those terms we are going to see today. Okay, so first term is what? Coefficient of compressibility. This we indicate by the symbol AV. Now be very careful about the symbols, because in the examinations many times they ask you only the name of the symbols in the match the following or in straight warmer questions. This is what? Coefficient of compressibility, and this will define for an NC clay. Now what is an NC clay? NC clay was the clay yesterday we have studied before. If you have not studied, NC clay is the clay where the present effective stress is what? Is more than the maximum past stress. We have already discussed that particular thing. So what you are going to do is we will plot a variation of void ratio. We'll plot the variation of what? Void ratio with the effective stress. Suppose the effective stress is changing from sigma 1 dash to sigma 2 dash. Sigma 1 dash to sigma 2 dash. So what type of plot we get? We'll get a plot something like this. We'll get a plot something like this. Yes. So now you see, corresponding to this sigma 1 dash, right? See, corresponding to this sigma 1 dash, I'll get some void ratio. Let me see. Corresponding to the sigma 1 dash, there is some void ratio. Suppose that void ratio is E1, right? And then corresponding to the sigma 2 dash, we will get some void ratio. Let that void ratio be E2. So you can see that when the effective stress changed from sigma 1 to sigma 2, actually it increased. Now you see, it is increased. There is increase in effective stress. So when there is increase in effective stress, there was decrease in void ratio, right? Right? Decrease in void ratio. So now, if we take a slope between these 2 points, that particular slope will be known as the coefficient of compressibility. Now how we find out the slope? Very easy. We know that slope is equal to what? Slope is equal to y2 minus y1 by x2 minus x1, right? This is how we find out slope, right? In coordinate geometry, we have already studied, right? Yes, average slope, I can say. So, if I want to find out the slope here between these 2 points, I will join to this point, 2 points, okay? I'll join these 2 points, okay? And what are the coordinates? E1, E2, right? And this is what? Sigma 1, sigma 2. So I can say the slope will be E1 minus E2, right? Divided by what? Your sigma 2 dash minus sigma 1 dash. And this average slope kind of thing is known as what? The coefficient of compressibility, right? So can I say this is nothing but the change in void ratio divided by what? The change in effective stress, right? Or the additional stress, right? Yes. So this, ladies and gentlemen, is what? The coefficient of compressibility. Okay? The coefficient of compressibility. Now, ladies and gentlemen, we will solve a question. Okay, we'll solve a question on finding the coefficient of compressibility. So you can take out your calculators, or if you don't need a calculator, you can do manually also. Okay, so I'll give you some time. So read the question carefully and answer this particular question. The question is, the void ratio of a soil changes from 0.7 to 0.6 when effective stress increases from 17 kilonewton per meter square to 17.5 kilonewton per meter square. Find the coefficient of compressibility. Please solve this question and give me the value. I'll give you some time. Okay. Read the question. It's very straightforward question, but such kind of straightforward questions are only asked in our examinations. Okay, many of the questions are very straightforward. You just need to be thorough with your formulas. Okay, the void ratio of soil changes from, this I can say is what? This is your E1, right? And this I can say is what? E2. When the effective stress changed from, this I can say sigma 1 dash, and this I can say what? Sigma 2 dash. Yes? Now, coefficient of compressibility means AV. That's very easy. That is the change in void ratio by change in effective stress. Yes? So this is nothing but 0.7 minus 0.6. Many students have solved it correctly also. Okay? Now some students might be thinking, sir, why we are solving so easy questions? Okay, every chapter starts with easy things, right? And slowly we move on to more difficult things, right? So change in stress, it is how much? 17.5 minus 17. So this is what? 0.1 divided by what? 0.5, giving us 1 by 5, or I can say 0.2. Now what will be the unit of this? Very important. You see, the change in void ratio. Void ratio don't have any unit, right? So it has no, you can say 1 unit less. Now, change in stress, that will have a unit of how much? Kilonewton per meter square. So 1 by kilonewton per meter square gives me what? Meter square per kilonewton. Right? So you see, so many types of questions can be asked from just this 2 slides. If you see these 2 slides, they can ask you so many questions, right? The first question they can ask is, if you plot void ratio versus effective stress for a NC clay, then what type of plot you will get? You can see that this particular type of plot, they will give you 4 graphs. They will ask you which graph is correct. So you should be able to identify. Then they can ask you the basic definition of coefficient of compressibility. What is the basic definition of coefficient of compressibility? That is the change in void ratio by change in effective stress. Then they can ask you the unit. Unit is how much? Meter square per kilonewton, right? And they can ask a very simple numerical like this. Okay, very good. Let us see the next term. The next term is compression index. The next term is compression index, and we indicate this by CC. We indicate this by what? CC. Okay. Now, for a NC clay, if you remember, coefficient of compressibility, I plotted graph between E and sigma, right? Void ratio and your effective stress. But if we plot between what? The void ratio E and then log 10 sigma dash. If you take the logarithmic, it's a semi-logarithmic plot, right? Then we are going to get a straight line like this. Yes, we are going to get a straight line like this. Now, if you see, the stress increased from sigma 1 dash, sigma 1 dash, sigma 2 dash, right? And then corresponding to that, I'll get certain void ratio, right? For sigma 1 dash, I'll get the void ratio of E1, right? And for sigma 2 dash, yes, I will get a void ratio of E2. Now again you can see that effective stress increased and void ratio decreased. But what is the difference? Here, when I'm taking a semi-logarithmic graph, I can say this is what? A semi-log plot, right? It's a semi-log plot. Then what is happening? In the plot between E and only sigma dash, I was getting a curved kind of thing, right? But here I get a straight line. And when it is a straight line, what happens? It is easier to take the slope, right? If you take the slope here, you can take the slope. It will be how much? You see, it will be E1 minus E2 divided by what? Now you cannot do sigma 2 dash minus sigma 1 dash. Why? Because here it is log. So it will be log 10 sigma 2 dash minus log 10 sigma 1 dash. Right? And this is the compression index. And this I can say is what? You said E1 minus E2. Can I say this is as what? The change in void ratio divided by. We can use the property of log, right? What is the property of log? Log A minus log B is what? Log A by B. So I can write down this as log 10, right? Sigma 2 dash by sigma 1 dash. Yes? So this is what? This is the compression index. So you see, the compression index and your coefficient of compressibility are very similar, but they are different, right? They're different. Let us solve a very simple question. So please solve this question, okay? So I am answering the question. You take your time and please solve the question. What is the question? The void ratio of a soil changes from 1 to 0.5 when effective stress increases from 10 to 100 kilonewton per meter square. Find compressibility index. So this is the question is wrong. Okay, here you can write down find compression index. Okay, I'll just correct the question. It is compression index. Okay, find your compression index. Please find out. It is straightforward question, but they will be asked in the examination. So you should be ready with such questions. Please solve it very fast. Okay, we have so many portions to complete today. Very straightforward questions, but there are such questions in plenty in your examinations. So don't think that our classes will be only theoretical and I will just pick up and you just, write down the notes or, just go into sleep mode. No, you have to solve the questions. Yeah. 0.5, very straightforward question. You see, compression index is what? The change in void ratio divided by what? Log 10 sigma 2 dash by sigma 1 dash. In the question, you can see that the void ratio changed from E1 1 to 0.5. So what is the change in void ratio? It is 0.5. Then divide by log 10. Okay, this is sigma 1 dash and this is sigma 2 dash. So 100 by 10. What is 100 by 10? That is 10, right? And what is log 10? Log 10 base 10. That is 1. So I get how much? 0.5. So this is what? This is how we find out compression index. Now can you tell me what will be the unit of your compression index? Can anybody say what will be the unit of compression index? What is the unit of compression index? Please mention in the comment section. What is the unit of compression index? A tricky question, but an easy question. Unitless, very good, very good. It's unitless. Very good, unitless. Such kind of questions will be asked in the examination. You have to be very attentive about each and every point. You see, change in void ratio. Unitless, I can place 1, no unit. Now see, logarithmic. Log of something, you will get what? Unitless, 1 by 1, there is no unit. There is no unit. So very important point. The compression index will have no units. Okay, now we will solve some true and false. Okay, some true and false questions. Yes. So yesterday also we solved some true and false questions. So some true and false questions for you. So straight true and false. You can write down T for true and F for false. The first statement is coefficient of compressibility for a particular type of soil is constant. Please, please, please write down it is true or false. Coefficient of compressibility means what? We're talking about AV. We're talking about what? AV. Coefficient of compressibility for a particular type of soil is constant. Please mention true or false. No, I don't write yes or no. Write down T or F. Because yes or no, which yes and which no. So T and F. Some people are writing false, many are writing false, very good. Some are writing true also. Yeah, it is false. It is false. You see, I'll explain why. You see, coefficient of compressibility, right? You see, in coefficient of compressibility, we are plotting between E and sigma dash. And we were getting a plot like this. We're getting a plot like this. Now, when I'm taking the slope, I'm choosing 2 points, right? Now you see the slope in these 2 points, right? And slope into other points, is it same? Is it same? No. So this coefficient of compressibility, it depends on effective stress, right? Can I say the coefficient of compressibility depends on effective stress? You see, as the effective stress is changing, the slope is also changing, so I can say it is not constant for a particular type of soil. Okay, it is not constant. The statement is what? It is constant. So that means what? It's a false statement. Understood, everybody? Yes. Now, the next question. The next question is, tell me this. Compression index for a particular type of soil is constant. Compression index for a particular type of soil is constant. Please mention true or false. Compression index for a particular type of soil is constant. Means CC, we are talking about CC. True, true, the answer is true. Yes, why it is true? You see, when I'm plotting the E versus what? Log 10 sigma, right? For finding compression index, I am plotting log 10 sigma dash. What is happening? I am getting a straight line, right? I am getting a straight line. So whichever 2 points you consider these 2 points, okay? Or you consider these 2 points, the slope is same, right? The slope is same. So therefore I can say it's a very important question and very important thing which they can ask you in the objective examinations, that your coefficient of compressibility, it depends on the effective stress, it's not constant. Whereas compression index, it is constant, it doesn't depend on the effective stress, right? So if I make a difference between these two, if I make a difference between these two, means what? If I make a difference between what? Your AV and your CC. What is the first difference? I can say the formula, the basic formula. It is change in void ratio divided by what? Your change in effective stress. Whereas compression index is what? It is change in void ratio divided by what? Log 10 sigma 2 dash divided by sigma 1 dash, the basic definition. Then the units. What is the unit? The unit of your coefficient of compressibility is what? It is your meter square per kilonewton. Whereas for CC it is unitless. Very important point. It is what? Unitless. Right? Then AV is not constant for a particular type of soil. It depends on effective stress. Right? It depends on effective stress. Depends on effective stress. Whereas CC is a constant value. I can see that all these type of things can be asked you in the examination, right? Now we saw AV, now we saw CC, right? Now we see another term that is known as what? Coefficient of volume compressibility, that is MV. See, we studied the term what? Coefficient of, we studied the term what? Coefficient of compressibility. You see, the coefficient of compressibility was AV. So understand the difference between these two terms. We get lot of confusions in this. So coefficient of compressibility is AV. Coefficient of volume compressibility is MV. It's a very straightforward relation. MV is equal to AV divided by 1 plus E1. Means what? This E1 was what? It was your initial void ratio. Initial void ratio. So if you can find out AV, if you can find out the coefficient of compressibility, right? Just divide by 1 plus E1, you will get what? Your MV. Now you see, some books write this also, AV by 1 plus E0. I told you some books write E naught as the initial void ratio, some books write E1 as the initial void ratio. That is fine. That is just a difference in the notations. It means the same thing, right? Now, tell me, the units will be same, na? The units of MV and AV will be same, na? Why? Because you see this 1 plus E term. E is what? Unitless. So 1 plus E is also unitless. So whatever unit of AV, I'll get the same unit per MV. So I can say the units will be how much? Will be what? Meter square per kilonewton. Okay? Now all these three terms means what? MV, AV and your CC we defined for NC clay, right? We defined for NC clay. Now, if we are defining for OC clay, what will happen? That term is known as recompression index, also known as what? CR. Now, we have studied yesterday lectures. Those who have missed yesterday lectures, they can visit that lectures also available on our official channel. We studied that in case of OC clay, there was recompression, right? In NC, it is compression. Why? Because in NC, the soil is experiencing the stress for first time. So it is only compression. Whereas for OC, soil has already experienced the stress before. So for the soil, it becomes what? Recompression, right? Yes. Okay. So now, for OC clay, if we plot a similar curve, E versus sigma dash. Okay. If you remember, for NC, we are getting a plot like this, right? Yes. But for OC, we'll get a plot like this. We'll get a plot like this. Okay. It's just opposite. It's a mirror image kind of thing, right? Now this is for void ratio versus effective stress. Now, if I take a log here, log 10 effective stress. Now, for NC clay, what was happening? For NC clay, it was a straight line, right? It was a straight line. But for OC clay, we'll not get exactly a straight line. We'll get a little curvy like this. Okay? And if you take the slope of this, will get what? The recompression index. And remember that this recompression index will be 1 by 5 to 1 by 10 times of what? Your compression index. Okay? It will be 1 by 5 to 1 by 10 times of what? Your compression index. Why such a thing is happening? Because the recompression will be less, right? Yes. Suppose something is compressed first. Okay. So it will compress more. But if you're going for recompression, it will be compressing less, right? Then for recompression index is what? 1 by 5 to 1 by 10 times of compression index. So now I can say that for NC clay, I have compression index, CC, right? And for OC clay, I have recompression index, CR, right? And we know what was NC clay. You know, NC clay, the present stress will be more than what? The maximum past stress, right? Maximum past stress, because the soil is experiencing the stress first time, so it will compress. But in case of OC clay, the present stress is less than the maximum past stress, so it is having recompression. So till now what we have studied, let us see. We have studied for normally consolidated clay, we defined three terms, right? Now everybody is aware with these terms. AB, coefficient of compressibility, CC, compression index, MV, coefficient of volume compressibility, right? Then we had OC clay. For OC clay, we normally use what? Only CR, that is recompression index. Now, why we studied these terms? Why we are studying these terms? Tell me. Why we are studying all these terms? Tell me. What is the topic of this? What is the topic name today? What is the topic? What we are studying today? Tell me. Please write in the comment sections. You might be thinking, sir, what we are studying? We are studying something else. Sir, why you are defining all these terms? Can you tell what we are studying today? Please mention what we are studying today. What is the topic name? What is topic name of today's lecture? Yeah. Topic name that is written in the name only. Not types of consolidation settlement. Okay. The topic name is consolidation settlement, means finding the delta H, finding the settlement of a clay layer when there is primary consolidation, finding delta H. But then why we studied all these terms? Why we studied all these terms? Instead of finding delta H, why I am studying AB, CC, MB, CR, all the terms we have understood very nicely, even solved the questions also. But why we are studying this compressibility parameters? These are known as what? I can say all these things are known as what? Compressibility parameters. Now why I am studying all these compressibility parameters? Why I am studying all these compressibility parameters? Because these compressibility parameters will help us to find out what? Consolidation settlement. We use these parameters to find out what? Primary consolidation settlement. So you cannot find out primary consolidation settlement without understanding these parameters. Now everybody is clear that why we study all these terms. Okay, and why instead of starting directly with consolidation settlement, why I started teaching you all these terms. Is it clear? If it is clear, then please write yes or no. If it is not clear also, you can write down no also. Be honest. So please mention in the comment section that till now, are you absolutely clear about what we are studying in this particular lecture? Please mention in the comment section. Great. See, I constantly interact with the audience because so that you don't sleep in the class. Some people might have just opened the mobile and they were not asleep in the class nicely, or you are in your bed and watching the mobile and you have slept in the class. So I keep on interacting with you and I'm asking you questions so that you become alert in the class. Okay, now let us see how we are going to use these parameters to find out this delta H. For that, we will study some derivation. So have little patience. If you have little patience, then you'll understand a very beautiful thing. Okay. Suppose this is our soil, saturated clay. This is what? Saturated clay. Now saturated clay I am mentioning in what? In your phase diagram. Saturated clay in phase diagram. And this is the initial condition. Initial condition means what? Before consolidation, right? I can say this is the initial condition. That means what? I can say this is before consolidation. Before consolidation. The initial condition of your saturated clay. Now this is a phase diagram. See, soil doesn't exist at top it is water, bottom it is soil. No. It is soil only, the soil mass only. I am representing in phase diagram. Okay, now you see. Now understand this very carefully. For the next 5 minutes, be as attentive as you can. Okay, please next 5 minutes be very attentive. Now see, this I can say is what? The height of the solids, right? The height of the solids. And this I can say is what? The height of the voids. Because all the voids are filled with water, right? All the voids are filled with water because it's a fully saturated clay. Now, this is the total height I can say, or initial height. This I can say is what? The initial height H. So H I can write down as what? H is your initial height. Initial height means before consolidation. Initial height of the clay layer. That is your initial height. Now, after consolidation, tell me, this total height will reduce, right? Yes, the soil will get compressed, so it will reduce. But tell me, the reduction will be in voids because the water will be in voids. So reduction will be in voids or solids or both. Please mention in the comment section. The reduction will be in voids or solids or both. Tell me. The reduction will be in voids or solids or both. Yeah, the reduction will be only in voids. See, solids are incompressible. So whatever reduction of volume will happen, that will be what? Only in voids. You can see clearly that the voids have reduced. So I can say the height of solid will be intact, right? Yes, the height of solids will be intact, but the overall height will reduce, right? Because the voids have reduced, so the overall height will reduce. Suppose this is H dash. And this is what? I can say this is the final condition. That is what? After consolidation. This is what? After consolidation. You can see that in the consolidation process, the volume have reduced, and the reduction in volume is due to expulsion of water from the voids. So voids will reduce, right? Solids will remain same. So this I can say H dash is what? It is your final height. Is the diagram clear to everyone? Yes, it is clear. Okay. Now can I say, you see this was the initial height and this is the final height. Can I say this delta H, ladies and gentlemen, this delta H is the consolidation settlement? Yes, this delta H is your consolidation settlement. This delta H is your consolidation settlement, right? This is your consolidation settlement. Yes. Okay. Now we will derive some relationship between these two and find out how to find out delta H. Okay. Now see. Suppose before consolidation the voids is E naught, and after consolidation the voids is EF, suppose. Okay. Okay. Now I can write down that before consolidation, I will write down before consolidation. Now be very attentive, as you have been great audience. So please be very attentive. And those who are seeing this lecture recorded, they also should be very attentive. Obviously, you can pause the video also who are seeing the recorded lecture. Okay. But still I will tell that you should be attentive because we are studying very important topic for your GATE. Okay. So before consolidation, after consolidation. Now see the diagram. Before consolidation, what is the void ratio? E naught, right? After consolidation, the final one, it is what? EF, right? Now before consolidation, what is the height? Height is H, right? After consolidation, what is the height? It is H dash. Very good. Now coming to the very definition of void ratio. What is void ratio definition? The void ratio definition is the volume of voids by volume of solids, right? Yes. Now, if you are finding E naught, now what is volume? Volume is area into height, right? Volume is area into height. So I can say area of the voids into height of voids by area of the solids into height of solids. Now see from the diagram, the area for voids and solids is same now. You see, this area is same now, only the heights are different. So I can say that this E naught will be what? I can cancel this area and I can write down the height of voids by height of solids, right? Now I can add 1 this side. See, the derivation is not important, and it is just to give you an understanding of things, okay? The derivation is not important. It's just to give an understanding of things. So be little attentive. Now you see what happens. So I can erase this. I'm getting what? You can see this is height of voids plus height of solids by height of solids. This is equal to 1 plus E naught. Now tell me, this height of voids and height of solids, is it total height? Yes. Height of voids plus height of solids is what? It is the total void, so total height. So I can write down this as what? H by height of solids. So I can say that this initial height is nothing but, I can take this side, it is what? Height of solids into 1 plus E naught. Can I write this? I can write it. Yes, I can write this. I'll erase all these things. So the initial height is equal to height of solids into 1 plus E naught. Similarly, this final height will be how much? This final height will be height of solids, because the height of solids will not change, na? You see, before and final means what? Initial condition and final condition. The height of solids is not changing, so that is constant. So I can write down this as height of solids 1 plus what? Final void ratio. Understood? Now somebody has not understood, that is also fine, because this is just a derivation. Okay, it won't be asked to in the examination. This is to give you some understanding of the topic. So from here what I can say, what is the consolidation delta H? Tell me, what is the consolidation delta H? That is your final initial height minus final height. Yes, you can see from this diagram. Yes, this is nothing but, you see, this initial height minus this final height. Yes, initial minus final. Okay, initial minus final. Okay, so what is the initial height? I can write down this term HS 1 plus E naught. For final height, I can write down this term minus HS 1 plus EF. Now what will happen? You see, I'll open the bracket. So this will be HS plus HS is to E naught minus HS minus HS into EF. Now you tell me, these two will get cancelled. I can take HS common. So HS into E naught minus EF. And what is this E naught minus EF? Can I say this as what? Delta E? Yes, I can say this as delta E. So all this thing changes to what? Height of solids into delta E, that is change in void ratio. Now, if you divide it by the initial height, that is H. Now what is H here? You can use this term HS into 1 plus E naught. Now everyone will be able to see a very familiar equation, right? Many of you have seen this equation, but today you have got the derivation, right? That this equation delta H by H is equal to delta E by 1 plus E naught. This equation forms the basis of your consolidation settlement. Now everybody knows from where this equation came into picture. Now the derivation is not important. You see, they are not going to ask you derivation in the examination. They are not going to ask you derive this equation. But you have got an understanding of this particular equation, right? So I will write down this equation just once, that yes, delta H by H is equal to delta E by 1 plus E naught. Lot of questions are solved from this particular equation only. Okay, and this equation forms the basis of our future studies also. Right? Now tell me, this delta H is what? It is your consolidation settlement. And now when I'm talking about consolidation settlement, I'm talking about primary consolidation only. Okay, so this is your consolidation settlement. What is your H? What is your H? H is your initial height. Very important, you should know it is your initial height. It is not your final height, it is your initial height. Okay, now what is your delta E? Delta E is your change in void ratio. It is what? The change in void ratio. And the last one, 1 plus E naught. What is this E naught? It is your initial void ratio. It is your initial void ratio. So now this equation is very clear to you. This equation is very clear to you. Now let us be ready to solve a question. Okay, let us be ready to solve a question. So this is your question. I am giving you the question. Find out the answer to this question. Okay, now what is the question? A clay layer of thickness 3 meter. That means what? This is the initial height, I can say, right? A clay layer of thickness 3 meter. I can say this as what? The initial height. This is what? 3 meter, has a void ratio of 0.9. So that means what? This is your initial void ratio. That is what? E naught. So whatever is given That I can say as what? The initial conditions. If during a consolidation process, it reduces by 0.19. So this is what? It reduces. It means what? The void ratio reduces by 0.19. That means what? This is your change in void ratio. Very straightforward question. They're asking you consolidated settlement. That is what? Delta H. But they're asking you in centimeters. So be careful. Find out the answer and tell me what is the consolidation settlement. Please answer the question using the basic formula which we just derived to you just before some time. Please find out the answer. Very straightforward question. Very straightforward question. Just 30 centimeter. You see this equation, delta H by H. Now you might think, sir, so easy questions, sir, so simple questions. No, this is the type of question they're asking in exam. Yes? See, things become easy when you study them. Nothing is difficult, right? Nothing is difficult. Things become easy when you study them. If you don't study, everything is tough. You see, from this I can write down delta H equal to this equation. Now you see, this is not having any unit. So whatever unit you want for delta H, you will put the same unit for your H. Now delta E, the change in void ratio is how much? It is 0.19. Then 1 plus E naught, initial void ratio is how much? 0.9. And H, which is how much? 3 meter, I'll express in centimeter because I want delta H in centimeter. So you see, this is 1.9. Get cancelled. I'm getting how much? 30 centimeter. So this is your consolidation settlement. If I ask you, find out the final height of clay layer. Can you give me the final height of clay layer? Can you give me the final height of clay layer? Find out the final height of clay layer. Can you give me this? Final height of clay layer. Suppose I'm asking you in meter. Final height of clay layer I'm asking in meter. Please give me the final height of clay layer. Very straightforward question. Now these are the question they will ask you in examination. 2.7 meter. Very easy question. So I can summarize this question as, okay, we have a clay layer like this, right? I can summarize this question as, we have a clay layer like this, okay? And this height was 3 meter. Now we found out the settlement. We found out the settlement of this clay layer as how much? We found out a 30 centimeter. That is what I can say, 0.3 meter. This is what? The delta H. I can say this is your initial height H. So what is your final height? Very straightforward. I can say this final height will be your H minus delta H. That is what? 3 minus 0.3 giving me 2.7 meter. Okay, this is your final height. Now many questions they can ask you from this particular equation only. Many questions. You see, there are how many parameters? Delta H, H, delta E and E naught. They might give you 3 parameters, ask you the 4th one, right? So many questions can be framed from this particular topic. Now till now you might be thinking, sir, very good sir, thank you very much sir for the lecture, and we got a very thorough understanding of how to use this equation. But you might be thinking, sir, where are the compressibility parameters? Why you taught us those parameters and wasted so much of our time? If this equation was so easy, I can directly use this equation, right? I can directly use this equation. Why there is a need for the compressibility parameters? The answer I will just tell you. The answer is, to use this equation, this change in void ratio you should know, na? Yes? To use this equation, you should know the change in void ratio. If you don't know the change in void ratio, how you will find out the settlement using this equation? right? Because the change in void ratio is initial void ratio minus final void ratio. Now, initial void ratio we know. Initial void ratio we know because that is before consolidation. But after consolidation, what will be the void ratio? You don't know. So this is unknown. If this is unknown, can I use this equation? No. From the calculations also you can see that we were able to find out the consolidation settlement. Yes, we were able to find out the consolidation settlement because we were knowing what? We were knowing the change in void ratio. If we don't know, we can't use this equation, and therefore there is need of what? The compressibility parameters that we'll see and end the class today. So suppose this is a clay layer, yes, and this is what? The mid depth of clay layer. Is the mid depth of clay layer, because all the analysis will do where? Will do at the mid depth of clay layer. Okay, and suppose this is your ground level. You can indicate like this, or we can make a beautiful tree like this. Okay. Now don't make a tree in your examination, just a joke. And this is your groundwater table. So this clay layer is saturated. The initial height is what? H. And we are interested to find out what? The settlement of this clay layer. We are interested to find out what? The settlement of this clay layer, delta H. Right? We are interested to find out this. Okay. Now, here, we know the initial void ratio. We know the change in effective stress. So, initially it was sigma 1 dash. Then, there was your additional stress due to many reasons. The additional stresses conditions we will see tomorrow, don't worry. And it become what? Sigma 2 dash. Okay. So now how we will use this compressibility parameters, let us understand. Now this equation is valid. Delta H by H is equal to delta E by 1 plus E naught. But I cannot find out this delta E. Why I cannot find out this delta E? Why I cannot find out delta E? Because we don't know the final void ratio. Yes. So here I will do some tricks. You see, we know compression index. What was compression index? Cc is equal to delta E by log 10 sigma 2 dash by sigma 1 dash. Right? Now we'll do some clever thing. So delta H is equal to delta E by 1, I will write down here. Delta H is equal to delta E by 1 plus E naught. What was the problem? Into H, obviously. What was the problem? The problem was we are not able to find out this delta E. What we will do? We will use the delta E from this equation. From this equation, delta E is equal to Cc log 10 sigma 2 dash divided by sigma 1 dash. So clever, right? So engineers are clever people. They know how to use mathematics, right? They know how to, use various things to get their answers done. And this delta E I will put here, and I get this beautiful equation which we use lot of times in our consolidation settlement calculation, that is Cc, right? This H will come into picture. So Cc into H log 10 sigma 2 dash by sigma 1 dash divided by 1 plus E naught. Now see, what was our problem? Our problem was we were not knowing the final void ratio. You see, we knew our sigma 1 dash, we knew our sigma 2 dash, we knew our initial void ratio, we knew our H, we didn't know our final void ratio. And we were able to find out the settlement using what? Compression index. Is everybody clear what we just did and how we derived this important equation? Is everybody clear about this? Please write down in the comment section, and also mention in the comment section that you understood this equation first time in your life. If you have understood that how this equation came into picture and why we need this compressibility parameter, if you have understood this first time, that also you can mention in the comment section, just to encourage me and cheer me up that yes sir, thank you sir, that you did a wonderful derivation for us. Very good. So now, this was one solution. We can have another solution also. What is the another solution? You see, our problem was we had this equation, but we didn't have final void ratio. Now, we also know MV, right? What was MV? MV was AV by 1 plus E naught, right? Yes. Now, what is AB? AB is delta E by delta sigma dash, right? And this 1 plus E naught will also come into picture. So from here, can I say that from here I can say delta E by 1 plus E naught is equal to, this will go this side, this will be what? MB into delta sigma dash, right? Now you see, in place of this, I can write down what? MB into delta sigma dash H. We got another equation of your consolidation settlement. You see? So, we got two equations. Now everybody understood, right? That why we studied those compressibility parameters and how to find out the compressibility parameters. Because if you don't know how to find out those compressibility parameters, yes, then you cannot use these equations. Let us summarize this today's class, and that will be the end of this class. We saw many things, but the summary is the most important equation is delta H by H is equal to delta E by 1 plus E naught. We cannot use this equation every time, because if you don't know the final void ratio, we cannot use this equation. So I can use the compression index and I get this formula, right? I get this formula, right? Using your compression index, right? And using your which index? With the coefficient of volume compressibility, I got another equation for what? Your consolidation settlement. This is what? MB delta sigma dash into H. Now you see, these two are defined for NC clay, right? Yes, 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 yes. Because for NC clay only, we defined what? Okay, compression index and your coefficient of volume compressibility, right? Yes, yes, for NC clay. Now for OC clay, what will be the change? For OC clay, the change will be very simple. It will be delta H is equal to, in place of compression index, I will use what? Recompression index. Okay, I'll use what? Recompression index, and the equation remains same. Now everybody is thorough about all the equations. Everybody is thorough about all the equations which we are going to use for what? For your primary consolidation settlement. For primary consolidation settlement, all the equations, all the parameters which are needed, we studied each one of them and understood everything about the equation and thorough understanding, right? Right? Very good. Okay. Now, in the next lecture, means tomorrow, this was what was? This was what? This was all the derivation thing. And we understood from where I am getting all these settlement equations, right? Now, tomorrow, very important session, tomorrow at 6 p.m., same timing, on the same YouTube channel. I will be solving questions and making you understand that how to use these equations to solve the questions which are asked in GATE, to how to find out the primary consolidation settlement. Okay, so this is the end of today's class. Okay, so this is my contact details. If you want to contact me, you can always contact me. You are welcome to contact me. Okay, if you don't want to contact me, no issues. You can see my lectures on YouTube. Yes, and also you can see my lectures in the BYJU'S Exam Prep app. Okay, if you download BYJU'S Exam Prep app, I have lot of lectures on various subjects which are mentioned there. Okay, so you can see those lectures also. Now, a homework for you. Okay, so homework for you. Always it's not like I will only teach and there will be no homework. The homework is, after you complete this particular lecture, have a go through the lecture, summarize the lecture, and mention in the comment section that what you have studied in this particular video in 2 to 3 lines. Okay, your homework is summarize summarize this lecture in 3 to 4 lines. Okay, now don't write out the equations. Don't write down the equation. Tell me that what you have studied in this particular lecture in 3 to 4 lines. Use your words, okay? Use your words, that how to do and all. Use your words, okay? And then write down in 3 to 4 lines. Okay, now why I am doing this exercise for you? Because if you summarize the lecture, you start summarizing the lecture, what happens? Then you understand that what you have actually studied in the topic. So this becomes a revision kind of thing, right? So summarize this lecture, and the best comment, and mention in the comment section. Summarize and mention in comment section, okay? Mention in comment section the summarization, okay? And I will select the best comment, okay? And I will select the best comment, and then I will mention the comment in tomorrow's class. In tomorrow's class, I will mention the best comment, okay? Okay, thank you very much. So hope you have enjoyed this lecture. So good night for now, but the lecture continues tomorrow, that how to use these equations. Okay, that is most important, because they're going to ask you lot of 2-mark questions. Lot of 2-mark questions in your GATE examination from these topics. So tomorrow lecture will be an important lecture. So all of you I want live. Okay, if you are not able to watch the lecture live, please watch the recorded one. Okay, but please do watch. Thank you very much. This is Satyajeet Sir signing off.